It's all good.
Okay, I'll reread it. So, human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. The blood types and the proportions given in the table above define a probability distribution, true or false.
Makes sense to be true.
Well, they add up to 1 when you add 0.45, 0.40, 0.11, and 0.04.
And it should be between 0 and 1, right?
They all together should add up to 1. So
Altogether.
since they all are between 0 and 1 and they add up to 1, then yes, I believe it is true.
I think so.
Yeah.
Okay.
I can read the next question. So question 4 says, what is the probability that a randomly selected person in the United States has type O blood, rounded to decimal places? So we'll use the chart from question 3.
Right.
Yeah.
So would that just make it the 0.45?
That's what I was thinking.
Cool.
Okay, I can read number 5. What is the probability that a randomly selected person will not have type O blood? That's the 2 decimal places.
So if the probability that they will is 0.45, then that would leave 0.55 to add up to 1, right?
Yeah, I agree.
Yeah.
Cool. So we ready for the next question?
Yeah.
My turn.
Yep.
Okay, so use the following information. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle one of the dogs, the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify a dish containing the specimen from the bladder cancer patient? Round answer to 3 decimal places.
Okay, so 6.
So that's 1 in 7, which is approximately 1.428 or 1.43, right? Or 0.143.
Yeah, 1.143. That's what I was thinking.
Okay.
Sounds good.
That's what I did too. I can read the next one. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate?
Um,
So you guys think there's little evidence?
yeah.
Um,
Well, they did get it right about 50% of the time.
it's yeah, it's like
Yeah. I
1% of
mean,
the time, but
When they should have only got it right,
I guess,
14%.
is there anything in the chapter that gives us a range of when we're supposed to justify strong evidence or little evidence? Because some people may say that 40% is strong evidence, but others may say that it's not.
Right.
So
isn't
that's
there
almost like opinion based.
isn't there a part about random chance in there though?
Yeah.
Randomness, yeah.
I'll try to
Yeah.
really fast.
Yeah, it's right. I pulled up the book. It's right underneath the rules of probability. So there's a section on randomness. It's 2.4. Story about the cereal. If you guys
Okay.
read it.
Yeah.
Well, not about the cereal, but about the store. The randomly choosing items.
Randomly.
So do we feel like 22 times out of 54 times is a repeating pattern? Because that's what it talks about, right? Is patterns.
Right.
Yeah.
Yeah.
I mean, that's a pretty
Big number.
steady pattern. Yeah, like
Yeah.
that's kind of the only thing I feel like.
We can always say that there is, and we'll find out after we submit it.
Best we can do, right?
Yeah.
Yeah. Okay, so in the next question, it says that we're going to be using this information for the next 3 questions. And it says M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. So the question is, if you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
That would just be simply 0.13, right?
Yes.
Okay, number 9. What is the probability that a randomly selected candy is green?
Take all those and add them together. 84
Is your guys'
point. I was
Is your
saying
guys' green section gone?
yeah, I think that's so we have to add all the other ones together and then
Right. I got
subtract it.
20.5 whenever I added them together.
Okay, because I got 0.84 when I added all of the other colors
Wait, I think
together.
I had a mix up. I was like,
Yeah, you have it.
actually, there's no way.
0.84 and then minus 1.
Right, so that
get-
leaves 0.16.
That's what I got, yeah.
Yeah,
Cool.
0.16.
So I guess then we've answered number 10 as well, because it says, what is the probability that a random selected candy is not green? It would be the sum of all
Yeah.
those or the 0.84.
Yeah.
Stop. So are we ready for question 11?
I am ready.
Yeah.
Okay. So let's see, what does that one say? It says the ACT scores of students admitted to a public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number?
I was thinking 24 because it says the median is 24.
Right. Isn't the mean the middle number, which is that top one, the 24.3?
Mean is
The mean is the average.
Okay. So I knew it was one of those two, either the mean or the median. But
You guys just totally broke up. You were talking about how the mean is 24.3?
yeah, we were talking about the difference between mean and median.
Okay. So the mean is just the average, and then the median is the one that's in the middle.
Yeah, so then the answer would be 24, right?
Yes.
Yeah. Okay. So question 12 says, based on the information on the table above, the top 25% of the students scored above what number?
Would that be the first quartile?
I think that'd
Yeah, I
be the
think-
Q3.
Well, is it the minimum though?
It's either the minimum or the first quartile.
Because it's
Because I
like
can't
minimum,
remember on the
first
box and-
quartile.
I can't remember if it's the space, like on your box and whisker plot, if it's like the space between the minimum and the first quartile, or if it's the first quartile.
Well, if you think about it, it's 25%, and that would be what we're kind of saying would work if it was split into 4. But there's 5 sections whenever it comes to this. There's the minimum, quartile 1, median, quartile 3, and then the maximum. So it's not like totally 25%. And no, but the minimum is 0.
Oh, yeah.
And so then quartile 1 could be the 25%.
I'm pretty sure it's quartile 1.
But also, I just realized, so it says the top 25%. So yeah, like Jake said, it'd be quartile 3, it's the top 25.
Or maximum.
Well, the maximum would be the top 1%. So they want all of the top 25. They want the minimum number. So I would think that'd be the Q3.
That makes sense.
I'm going to go with that too.
What did you guys decide?
The Q3 or 27 would be the number we're looking for.
So I submitted mine and I got 100%.
Sweet.
What's that?
This was much faster than last week.
The last quiz last week, that was so time consuming.
Yeah, I wonder if it'll be the same on Thursday again.
Yeah.
Well, it really depends on what questions we have on the individual preparation, right? And then how long the quiz takes.
Yeah, last week we had a lot of SPSS files, so I mean, it took us probably this long just to download all of the files to answer the questions.
I'm sure.
All right, so 7 o'clock work for everyone again on Thursday?
Yeah, it works for me.
Okay, thanks, Emily.
Yeah, I'll post it. See you guys.
See ya.
ya.